Today's video, I'm going to talk a little bit about what we talked about yesterday, which was solving inequalities, but this time we're going to apply it to rational inequalities. So just a couple of things that are a little different, but most of it's pretty much the same, right? So just like before, we want to make sure that the inequality is always set compared to 0, right? So we always want to make sure first that it's either less than or greater than 0. Because all of this only works if we're comparing it to 0. All right, so in this case, we still want to do any factoring that we can, so that the numerator is already factored. So we'll keep that the same. And then on the bottom, we've got x plus 3 and x minus 3. Right. So we're going to do just like before. We're going to make our number line. And then on our number line, we're going to mark anything that would make stuff 0. Now, the one thing that's different this time is we've got zeros on the top and zeros on the bottom. So we have to keep track of the fact that if I have a 0 on the top, that's fine, because 0 divided by something is 0. So we're going to have negative 2, right? That's a 0. But then down on the bottom, what would make the bottom 0 would be negative 3 and 3, but those are on the denominator, right? So that means that I can't divide by 0. So I like to kind of put a little, maybe a little note here. This is undefined and undefined. Sometimes another thing that might be helpful is like when you make your table here, dash those, because, right, no matter what, we can't include 3 and negative 3 because they're in the denominator. And we can't include them because that would make the denominator 0, which is undefined. So everything else, though, is going to be the exact same. And we put our factors over here, x plus 2, x plus 3, x minus 3. And then we start picking numbers, right? So pick a number less than negative 3, like negative 4. Pick something between negative 3 and negative 2, so maybe negative 2.5. Pick something between negative 2 and 3, like 0, and then something bigger than 3, like 4. And we plug those into our different factors, right? So negative 4 plus 2, negative, negative 4 plus 3, negative, negative 4 minus 3, negative, negative 2.5 plus 2, negative, negative 2.5 plus 3, positive, and negative 2.5 minus 3, negative. Plug in 0, we're going to get positive, positive, negative. Plug in 4, and they are all positive. And so we can do just like before, even though technically over here it's not all multiplication. It is, because it's multiplication and division, right? So what we've got here is we're saying, well, this is on the denominator, right? It would be a negative times a negative, so that's positive. And then on the top, it's negative. And so a negative divided by a positive is going to come out negative. But really, you don't even have to keep track of, is it multiplication or division? It's the same as before, so you would just say a negative, a negative, a negative. That's going to be negative. Okay? And then this one would be positive, negative, positive. And then so for this problem, right, we want to see when is it negative or 0. So if I come up here then, so it's negative here, it's negative here. And then where is it 0? Well, just at negative 2, right? So negative 3 and 3, we did need to list them because they made the denominator 0. So that would have been a place where it switched possibly from positive to negative. But we would not want to include those values because they make the denominator 0, right? And the denominator being 0 is not okay. So if we want to say then where is it negative? So from negative infinity until I get to negative 3, but I can't include negative 3 because that is broken there, right? So I wouldn't want to include it. Then it starts back up again at negative 2. Negative 2 we can include because that would make the top 0, and 0 on the top is fine. And then I take that to 3. Again, I cannot include the 3 no matter what, because that is a 0 on the denominator. And so there's our final answer, right? So that is when that rational function is going to be less than or equal to 0. All right, let's try another one. So again, we always have to factor it first. So, or find out what makes it 0 if it doesn't factor. All right, so the numerator here would factor to what? X plus 5, x minus 2, and the denominator is going to be x plus 4 and x minus 2. So notice that x minus 2 actually cancels out here, right? But we still want to put 2 on our number line because things might have actually happened there, right? So I always go ahead and list it. We wouldn't, yeah, so, okay. Because the other thing to keep in mind then is that 2 was a problem, right? Because I can't divide by 2, 2 minus 2, which would be 0. So, all right, so I'm going to put a dashed line there. I'll put a dashed line at -4. Again, if it also helps, you might put like undefined, right? Because those were in the denominator, right? So anything that was created by the denominator, so even though the x minus 2 is in the numerator, the fact that it was in the denominator as well means it's a problem, right? So there's going to be a problem at 2 and a problem at -4. -5 is going to be regular old 0, okay? So we got x plus 5 and x plus 4. Now, we do not need to list x minus 2 as a factor because it canceled out. So since it canceled out, we don't need to bother listing it. If you want to list it, you can. However, you'd have to list both of them. So might as well just cancel it out. Okay. So then, come up here. So let's pick like -6, -4.5, 0, 3. All right, so I plug in -6. This is negative and negative. So negative divided by a negative is positive. -4.5, this is positive, negative. So that's going to be negative. 0, we've got positive, positive is positive. And 3 is positive, positive, positive. So I want to know when it's greater than 0. Right? So greater than 0 is going to be where is it positive? So that's here, here, and here. So again, because we took the time to put the 2 on there, it helps us then when we're reading our answer, right? So this is going to be from -infinity until I get to -5, right? It was positive there. I don't need to include the -5 because I just wanted to know when it was greater than 0, so I don't need to include it this time. And then it's also positive from -4 to 2, and then from 2 to infinity. So notice that by listing the 2 there on the number line, it helped us remember, oh yeah, can't include 2 because that would be the denominator 0. Okay, so there's that one. All right. If you wanted to pause the video and try this one, you can. And then, but I'll go ahead and work it out here. So when we make our number line, so 3x plus 5, so that would be 0 at -5/3. Right? The denominator there of x would be 0 at 0, but again, that's where it's going to be undefined because that 0 is in the denominator. And then a 2. Okay, so then my factors are 3x plus 5, the absolute value of x minus 2, and x. So the x minus 2, because it's an absolute value, right, we can just go ahead. We know that that's going to be positive, 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 positive. Okay. So -5/3, so we'll just come down to like -10, right? And then we could go -1 and 1 and 3. Okay, so -10, so this is going to be at negative, and then -10, so negative. So when I multiply and divide a negative, positive, negative, it's going to come out positive. Plug in -1, this is going to be positive, negative, so negative, and then at 1, positive, positive, and at 3, we are positive and positive, so positive. All right, so I want to know when it was less than 0, so just where is it negative? So in this case, the only place it's negative is right there. So my answer then would be from -5/3 until I get to 0. let's say I had asked you to do less than or equal to 0 for this one, right? What if all that stuff was less than or equal to? So that one then, if I want to do less than or equal to 0, now I would need to include the negative 5/3, right? So negative 5/3 until I get to 0, right? But I still can't include the 0 because it was broken at 0. And then if I want to know when it's less than or equal to 0, I would also need then to say, well, over at 2, right? Over at 2, then it would be equal to 0. So I'd have to list that value as well. So adding the equal to, right, would add in the fact that I now need to include those zeros. All right. Let's just do a couple here where it's dealing with where it's not compared to 0, right? So this is going back to yesterday, but we've got a little bit of work to do here because it's not compared to 0. So I would first distribute that 4x squared, or 4, and get 4x squared minus 16x. And then I can subtract my 9 over. And so I'm going to have that. So now I need to factor that. So let's see, probably 2x and 2x. And let's see, what can we do here? What if we do 9? I think if we do 9 and 1, does that work? So negative 18 and positive 2 would add up to negative 16. All right. So now we've got it factored, so now we can make our number line. So again, just remember that in all these problems, right, you have to always get it greater than or less than 0, right? So the fact that this was greater than 9, that doesn't help us. Everything has to be compared to 0. So then we're going to have, when I set 2x plus 1 equal to 0, then I'm going to get a 0 at negative a half. And then 2x minus 9, I'm going to get a 0 at 9 halves. So over here at 9 halves. And so then I make my chart. So this one's pretty quick since it's just a couple of factors. So I've got negative 1 would work, 0 would work, 6 would work. Okay, so negative 1 times 2 is negative 2 plus 1. That's going to come out negative. This one would be negative. So a negative times a negative is positive. Positive, negative, so negative. And positive, positive, so positive. And so again, I wanted to know when it was positive, right? Because when is it greater than 0? So that's going to be here and here. So from negative infinity till I get to negative a half. And then from 9 halves to infinity. Right? And again, I don't need to include the negative half and the 9 halves because in this case, I don't want to know when it equals 0. I just want to know when it's greater than 0. All right, let's do one more here. Similar idea. Notice that it's not compared to 0, right? So the first thing I'm going to have to do is subtract that 3 over. So I've got 4x plus 5 over x plus 2. Subtract the 3. But now I'm going to need to get a common denominator, right? So I cannot do what I've been doing until I get that common denominator. So this is going to need an x plus 2 over x plus 2. Right? So now that I've got a common denominator, I'm going to have 4x plus 5 minus 3x minus 6 all over x plus 2. So up top, that gives me what? X minus 1 and x plus 2. There we go. Okay. So now I can make my chart. So a little bit of algebra required there to get it set up. Right? So then I'm going to have a 0 at negative 2, but that one's in the denominator. So I'm going to make that a dashed line right undefined so I remember when I go to make my chart. And then at 1. 1 is fine because that's up in the top. Okay, so I got x minus 1, x plus 2. So we could pick like negative 3, and 0, and 5. So negative 3 minus 1 is negative. Negative 3 plus 2 is negative, so that'd be positive. Negative, positive, negative. Plugging in 5, they're both going to be positive, so positive. And so I wanted to know when it was greater than, so positive, or equal to 0. Right? So where is it positive? Positive here, positive here. Where is it equal to 0? at 1. Right? Not at -2, though, because at -2, the 0 is in the denominator. So we're going to say from negative infinity until I get to -2. I cannot include the -2, and then go from 1 to infinity. I can include the 1 because that is on the top. Okay. And then there's one last little application here, kind of hearkening back to the first or second chapter that we did, the second unit that we did back, when we talked about domain, right? How do I find the domain of this? Well, I know that the domain is when x cubed minus 16x is greater than or equal to 0, right? I know that if I take the square root, it has to be positive under there. So basically what we've done now is we've set up an inequality that we now know how to solve, right? So if I factor out the x, I'd have x squared minus 16. That will factor to x plus 4, x minus 4. And I can set up my number line. I'm probably starting to get pretty good at setting these up, hopefully. A little bit quicker. So what would make it 0? 0, -4, and 4. Right, so then we've got our factors, x plus 4, and x minus 4. Right, and so then let's pick -5, and -1, and 1, and 5. So this would be negative, negative, negative. So that would come out negative. If I pick -1, it would be negative. Positive, negative, so that's positive. Pick 1, positive, positive, negative, so that's negative. And 5, they're all going to be positive, so positive. So again, I want to know when is it greater than or equal to 0. Right? So that means where is it positive or equal to 0. And so it equals 0 at -4, 0, and 4. So now I can say that where is it greater than or equal to 0? Well, starting at -4 until I get to 0, and I would include those because that's what makes it equal 0. And then if I pick anything from 4 to infinity, and again, I can include that 4. So there is the domain of this function up here. So what this is saying, right, is that if I pick any numbers from -4 to 0, then this part will come out positive, and I can take the square root of a positive number. And then if I pick any numbers greater than 4, this again will come out positive, and therefore I will be able to take the square root of it. All right, there are some practice problems for you to try, and good luck.